Every year, millions of pounds of salmon are harvested from some of the coldest and cleanest waters on Earth. From the rugged coastlines of Alaska to high-tech factories across North America, these fish go on a remarkable journey, ending up sealed in metal cans, ready to feed millions of people worldwide. Canned salmon is a household staple, affordable, nutritious, and shelf-stable. But how does a slippery, freshly caught fish turn into something so convenient? Today, we're going deep inside the world of canned salmon production, step by step, from sea to shelf. Salmon destined for canning are typically harvested in massive quantities during their seasonal runs, especially along the coasts of Alaska, British Columbia, and parts of the Pacific Northwest. The most common species used for canning are pink salmon and sockeye salmon. Pink salmon is prized for its mild flavor and soft texture, ideal for large-scale canning, while sockeye offers a richer color and taste. The fishing season is short and intense. During peak weeks in summer, a single boat might haul in tens of thousands of pounds of fish in a single day. While wild salmon is still highly prized, today a significant portion of the world's canned salmon comes from salmon farms, a system known as aquaculture. In places like Chile, Canada, Norway, and Alaska, thousands of salmon are raised from eggs to adulthood in carefully managed ocean pens or land-based tanks. The process begins in hatcheries, where fertilized eggs hatch into small fry. These young salmon are nurtured in freshwater tanks until they're strong enough to be moved to the ocean. In ocean pens, they spend up to 2 years growing to harvest size. Farmers monitor water quality, oxygen levels, and feeding routines daily. Their diets are formulated to mimic wild nutrition, with sustainable fish meal and plant-based ingredients. These farms allow for consistent, year-round supply and reduce pressure on wild salmon populations, though they also raise debates around sustainability, disease control, and marine impact. When harvest time comes, the fish are collected, quickly stunned for humane handling, and chilled, ready for transport to the processing facility, just like their wild cousins. Once the boats dock, the salmon are quickly transferred into chilled containers or iced bins to keep them cool and fresh. The journey to the processing plant begins, usually within a few hours of the catch. Most salmon processing plants are located near the coast to reduce transportation time. Every hour saved is critical to maintaining flavor, color, and safety. At the plant, the fish are weighed, tagged, and queued for processing. Inside the facility, the first step is inspection. Trained workers and automated systems sort the fish by species, size, and quality. Only the best fish are selected for canning. Fish that are bruised, too small, or not within size standards may be diverted for other uses, like pet food or fish meal. Next, the salmon are cleaned to remove surface contaminants. A series of high-pressure water jets and soft brushes remove dirt, scales, and blood residue. This step must be done quickly and hygienically, because the clock is ticking. Next comes butchering. Salmon are automatically fed into specialized machines that decapitate, eviscerate, and trim each fish in seconds. This step removes all inedible parts, leaving behind only the body cavity, rich in meat and natural oils. In some plants, certain batches are hand-trimmed for export-grade quality. Some canneries leave the bones and skin intact, especially in pink salmon, since the bones soften during cooking and provide valuable calcium. Once cleaned, the fish are ready for the cooking stage. Before the salmon can be canned, it goes through a critical step: pre-cooking. This process not only makes the fish easier to handle, but also helps lock in flavor and nutrients. In most modern canneries, the salmon is placed on trays or racks and moved into large steam ovens, also called cookers. Depending on the species, cut, and plant protocols, the salmon is cooked at temperatures between 180 degrees Fahrenheit and 212 degrees Fahrenheit, 82 degrees Celsius to 100 degrees Celsius, for up to 1.5 hours. This initial cooking phase softens the bones, especially for pink salmon, so they become edible and rich in bioavailable calcium once canned. Unlike many meats, salmon is often canned with its skin and bones intact, which not only preserves texture and flavor, but also increases nutritional value. especially protein, omega-3 fatty acids, and minerals. After cooking, the racks are removed and cooled slightly to make the fish easier to handle. Depending on the product type, workers may remove skin and bones for premium boneless varieties, or simply break the fish into chunks for traditional canned styles. Now comes the heart of the operation, filling the cans. Cans are first washed and sterilized before reaching the filling line. Then, precisely weighed portions of salmon, either chunks or minced, are placed into each can. Most plants use automated portioning systems, but some premium or specialty lines are hand-packed to maintain integrity and visual appeal. Next, a small amount of salt or seasoning may be added, depending on the recipe. But most canned salmon is packed in its own natural juices, without added liquid. This method allows the salmon to cook further and release its own oils during the final sterilization phase, enhancing flavor and extending shelf life. Once filled, the cans are sealed with airtight lids using a high-pressure double-seam sealer, ensuring no air or bacteria can enter. But the journey isn't over yet. These cans now need to be sterilized, not just cooked, to ensure they're safe and shelf-stable. Once the cans are filled and sealed, it's time for the most important safety step in the entire process: thermal sterilization, also known as retorting. Canned salmon must be shelf-stable for years. That means it needs to be completely free from bacteria, yeast, and pathogens like Clostridium botulinum, which can't survive high heat and pressure. The sealed cans are loaded into large retort chambers, giant pressure cookers that resemble submarine doors. Inside, they are exposed to temperatures as high as 250 degrees Fahrenheit, 100 degrees, under 15 psi, pounds per square inch of pressure. This process lasts between 60 and 90 minutes, depending on the size of the can and the contents inside. The intense heat penetrates the entire can, cooking the salmon further, while also killing any remaining microorganisms. Operators monitor the process using automated control systems to ensure perfect sterilization without overcooking, which could dry out the fish or break down its texture. This balance between safety and flavor is what makes canning such a science and such an art. After the cycle is complete, the cans are gradually cooled using water sprays or immersion tanks to bring their temperature down safely. Once cooled and dry, the cans are ready to be labeled. Each can receives a wrapper indicating the species, pink or sockeye, net weight, nutrition facts, and expiration date. Some labels also note whether the salmon was wild-caught or farm-raised, giving consumers insight into origin and sustainability. Next, the cans are packed into trays, shrink-wrapped, or boxed into pallets, ready for shipping to supermarkets, restaurants, and pantries across the world. From small-town grocery stores to global food chains, these humble cans carry both nutrition and tradition. Behind every can of salmon is a journey that begins in icy oceans or carefully managed fish farms and ends in your kitchen, packed with flavor, nutrients, and decades of food science. It's a story of precision and preservation, of ocean harvests and engineering excellence, all sealed in a simple metal can. And while it might seem ordinary, canned salmon is one of the most dependable sources of protein on Earth, feeding families, fueling emergencies, and connecting people to a global food chain they often never see. So next time you open a can, remember the journey behind it. If you found this process fascinating and you want to see how more everyday products are made on a massive scale, don't forget to like this video, subscribe to our channel, and hit the bell icon so you never miss a behind-the-scenes look into the industries that feed the world. Thanks for watching. Stay curious.